motivational speech that I just gave you is this chapter is hard. I'm going to tell you that right now. Okay? This chapter is long. And I'm also going to tell you this. Let me look at my calendar here. So like right now, you are going to have a quiz on March 9th. That's my plan. And a quiz on March 22nd. So you'll have 2 quizzes from this chapter. And then it's the end of the quarter. And the reason I tell you that is because quarter 4, there's not a lot of points. We cover chapter 9 and smarter balance testing. Okay, we have to front load so much that there's not going to be as many points in quarter 4, and we'll talk about that closer to quarter 4. But we will not finish chapter 8 until March 29th. This will take us an entire month to do because there's so many little tiny details that you don't want to miss out on. Okay, so some of you did pretty well at the beginning of the last chapter, and then you kind of fizzled off towards the end. Just because you finish it in class doesn't mean you should not look at it at home, right? Did you have to do every problem on the 3rd attempt, the 3rd check you got it right? That's an issue. Okay, don't wait until the day before a quiz or wait till the day before a test to go like, I didn't really understand 7-5. Not a good idea. Okay. Chapter 8 is on polynomials. So terms are separated by a plus or a minus sign. A math phrase with multiple terms is called a polynomial. Poly means many, like a polygon, many sides. Okay? So terms are separated by a plus or minus sign. If you're multiplying or dividing, that's still part of one term. So if there's one term, the name is a monomial. Mono means one. M-O-N-O-M-I-A-L. An example of that would be 5 or negative 3x squared or 7y cubed. Nothing added or subtracted, just one chunk. Those are 3 separate ones. Does that make sense? Okay. 2 terms. Binomial. Binomial. So we could have x plus 5. We could have 3y minus 17x squared. We could have negative 12x squared y cubed minus 3y. As long as there's no plus or minus in there, that's one term. What'd you put in here?
I don't know. I just hit the start button.
Oh, it smells good.
Oh. Water.
I just put water in it today.
Oh, well,
I didn't even put any stuff in it unless somebody did. 3 is called a trinomial. X squared minus 3x plus 7. 12y squared plus 15xy minus 7y x squared, I meant to write. 3 separate chunks. You're not doing anything with them. We're just talking about how many terms there are. And then anything over 3 doesn't have a certain name. We just group that all in polynomial. So anything with over 3, we just call a polynomial. And I'm going to give you a really nasty long one. Ready? 15y cubed minus 7y squared plus 12xy minus xy squared plus 3. Every time there's a plus or minus sign, you have a new term. So technically this has 1, 2, 3, 4, 5 terms. All of this chart is just terminology. It's vocab. Okay? It may say multiply the monomial into the polynomial. You have to know like, oh, I'm going to take one term times many terms. Does that make sense? Factor the trinomial. Oh, I'm going to have something with 3 separate terms in it that I'm going to factor. All right. The degree of a polynomial is the greatest degree of any term. So we define something by using the word. That doesn't help us a lot, Ms. Hoff. To find the degree of the term, you add the exponents. Determine the degree of each term. Okay? Every term is separated by plus or a minus. So if we take our first polynomial, you're adding the exponents of every term. The term is -9. What is its degree? 0. It does not have a variable. So that has a 0 exponent. -5w cubed. Degree? 3. The exponent is 3. 7w. 1. 9w to the 5th. 5. If it's a constant, a number without a variable, the degree is 0. Okay? The degree is 0. Now, that's the degree of each term. To figure out the degree of the entire thing, we pick the highest number. 5. So the degree of that polynomial is 5. Go to the middle one. Try it on your own. Tell me the degree of every term, and then tell me the largest. First one, degree 3, then 0, then 1, then, so the degree of the entire thing, 3. Got this. Now I have multiple letters. If you have multiple letters, you add the exponents together. First term, 6w, degree 1. Second term is 15 v squared w cubed y squared. Degree 7. Next term, 5. Degree 0. Next term, -y to the 5th, v to the 6th. 11. What is the degree of this entire polynomial? 11. Questions on degree, because it's going to impact our next piece as well. Add your exponents. If it's a constant, a number without a variable, 0. Go ahead. Okay. To write a polynomial in standard form, you must put the exponents in order from the greatest to the least, then identify the leading coefficient. Leading means out front. What's a coefficient? Number in front of your variable, right? So once we write this in standard form, highest exponent to lowest exponent, we need to tell them what the starting coefficient is. So if we look at the polynomial, 3x squared plus 4x to the 5th minus 7x. What's your highest exponent? 5. That term goes first. So what are you going to write first? 4x to the 5th. That takes care of this term. What would be the next term? Very good. 3x squared. Is it a positive 3 or negative 3? So you know to put a plus 3x squared. And last but not least, minus 7x. Very good with the minus. After it's in standard form, they ask for the leading coefficient is 4. 4. Go down. Do this one on your own. Highest exponent to lowest. First one I should write down. Negative, I always put a 1 out there. Negative 1u to the 6th. Then negative 5u to the 3rd. Negative 18u plus 7. Your leading coefficient? Negative 1. I don't think we really need to do 2 more of those. Are you good? Yeah.
What if it's the same variable? Like, okay, both one.
You won't worry about that. If they're going to be 2 separate, if they're the same variable, we'd have to put them together, which we're going to talk about in a minute here. But if like one was an X and one was a Y, you pick which. Usually I go alphabetical, if I'm being honest. Okay. So also on top of this, we are going to add or subtract polynomials. Involves adding like terms. Now you guys know what like terms are. We always say combine like terms. In your definition, not like a textbook definition, what's a like term? What are things that you can combine? Same variables. And I'm going to build on it because it's a polynomial. And we're going to have different exponents. They have to be the same variable and exponent, right? So like in your guys's, when you would be solving, it'd be like 7x plus 3 minus 2x. Which ones are like terms? 7x and 2x. They both have an x to the first power. Follow me? So same variables with same exponents. If I add a squared over here, I no longer have like terms. Does that make sense? An x and an x squared is like, I have 7 apples and 2 oranges, so I have 9 pineapples. No, you don't. You have 7 apples and 2 oranges. Don't put things together that have different exponents. Okay. The difficult part about this is not trying to do it in your head. People try to do it in their head, and they have messy handwriting, and it goes poorly. Find each sum. Sum means to add, or difference. Difference means to subtract. Straightforward. But there's parentheses. All this is telling you is this is a polynomial, and I'm adding this polynomial together. Okay? When you're adding, do the parentheses matter? No. So now we just need to combine like terms. So Miss Hoff gets her shapes out. Okay? I am going to put a circle around 7x squared. Is there any other term that should be combined with y squared, sorry? Y squared. Technically, what number's in front of y squared? A 1. So when I add them together, I get 8y squared. Only change the coefficient. Now I get my next triangle out. A square. 5. Who does 5 go with? 6. 5 plus 6 is 11. And last but not least, I have negative 2y. Does he have anybody to go with him? Nope. So we write minus 2y. Last but not least, you have to make sure this is written in standard form. Highest exponent to lowest. Is it there? Okay, what should be first? 8y squared minus 2y, good job bringing the negative, plus 11. Done. So how can people screw this up? Yes, good question. How can people screw this up? The parentheses mean here's a polynomial and here's a polynomial, but this time I am subtracting. How does that make this difficult? You have to subtract everything. So the very first thing I would do, distribute that negative sign. The odds of you remembering to go back and bring that negative sign with you, slim to none. So on the adding one, I didn't make you rewrite it. When you're subtracting, rewrite it. This negative 1 needs to multiply by everything inside there. So 5v minus 7, the front polynomial does not change. But now what do I have? minus 2v squared plus 1v plus 7. Now go back to your shapes. What can be combined with 5v? 1v for a total of 6v. What can be combined with negative 7? Positive 7 for a total of, do I need to write plus 0? No. And then last but not least, negative 2v squared. Nobody goes with him. Can I circle that? What should go first? Negative 2v squared plus 6v. Plus 6v. Got this. Are you worried, Jackson? One polynomial plus another polynomial minus this guy. Adding, no big deal. The subtracting is where we have an issue. This has to be distributed. The first thing I would do, rewrite this. Don't change the first one. Negative 4x squared plus 8x plus 4. Then I should write minus 8x squared minus 5x minus 5 plus 1x squared minus 2x minus 2. On your own, now that we've distributed that, go and combine your like terms, put everything together that you can, and before you circle your final answer, make sure it's written in standard form. I got negative 11x squared plus 1x minus 3. And the nice thing is, ended up in standard form already, right? Okay. So how could you make this any harder? Let's go to the bottom right. It's different. There's more variables than just one, right? So now if we're going to talk about like terms, every variable and exponent have to match to put them together. Okay? First thing I should do on this, distribute your negative. Be careful when you're writing. Sometimes your guys' exponents get to be as big as your coefficients. So 6x cubed y squared plus 4x squared y cubed minus y cubed plus 2x squared y cubed plus or minus 3 plus 3x cubed y squared minus 7y. Question? Because the only reason the parenthesis is there is to just identify that this is its own polynomial and I'm subtracting this polynomial. So really the parentheses are never going to impact the first one. It's the second one because if you're subtracting, you have to distribute that negative sign.
So after you distribute, would it be like still having the first one in parentheses?
Oh, you don't need the first one in parentheses. Nope. The parentheses just signify this is the first polynomial and I'm subtracting this one. Okay. 6x cubed y squared. Anybody to go with him? This guy? So how many total do you have? 9x cubed y squared. How about with your 4x squared y cubed? Okay, for a total of positive or negative? Plus 6x squared y cubed. Negative 1y cubed. Negative 7y cubed. Negative 8y cubed. Here's what I'm going to tell you. This is what Sophia was just asking me a minute ago. We have some like multiple letters. If it has multiple variables, don't rearrange it. Just leave it. I will not count it wrong for standard form purposes. Okay? Just leave it. Do we see where there's little ticky-tack things that could throw us for a curveball today? So just make sure you can read your own handwriting and make sure you pay attention to detail. You know where the biggest mistake is made? Writing it from your screen to your paper. 90% of the time, the first thing I do when you guys come and ask me for help, I check what the problem is, right? A lot of times you just transfer it incorrectly. So just double check that. Before you get into Alex, turn your laptops on and wait for further instruction.